Hello, and welcome to this tutorial video. This video will be the first of a series to teach you all you need to know in order to CAD a VEX robot. Now let's get started. The first thing we got to do is actually start our assembly. You can either click here on the home menu of Inventor, or go New, click Standard.iam. You don't want to do this is something else. You want Standard Inventor Assembly. So we'll double click that. Now what we got to do now is place our parts, because we can't assemble anything without any parts. So up here, you want to do place. Do not do place from content center. Sometimes it will default to that. We just want place. So we hit place. Now these are just all my parts. Now I have all my parts in this library here. You may have your own library, that's fine. But I've done some things to make this part library easier to use. So we're going to start off with a basic wheel mount. So I'm going to go to my metal, C channels, and I'm going to say we're going to use a 10 long. So I'm going to place two of these. I'm going to hit right click. I'm going to push OK because that means I'm done placing my parts. And what I always like to do, I like to ground one of my first pieces. And you just right click your piece and click grounded. What this does is this piece can no longer be moved, but this piece can. And the reason for doing that is when we start constraining things, this will make sure that our views are all nice and square with our part, as you can see here. And let's say you ever get somewhere lost and you can't see what you're doing. You can always click the home button here. It'll bring you back to your view. Now my preferred way of moving around my screen, just a useful tip, if you push down on your scroll wheel, it'll grab the screen and you can drag it back and forth. And then releasing just lets it go. And again, you just hit home. Okay, so that's just a few basics of Inventor. One more thing, I also like to use this orbit tool here. This orbit tool, once you click it, it's just on the right over here. You can click and drag in the middle. You can change your view. This will be a lot more useful later. Or you can click and drag on the outside to rotate your part. So that's how you can navigate and look around your part. Alright, and then once I'm done with it, I can either press escape, or I like to just hit right click OK. And then hit home again. Alright. Now we're actually going to place some standoffs, because we're going to be creating a small wheel mount. Essentially what we're going to be doing is just teaching you the basics of how constraints are used to put parts together. And it's very simple. This constrain tool up here is essentially what you'll be doing for all your VEX assemblies. I don't know anything else that you would be doing. So what we're going to mainly be using in this is mates and flushes. Sometimes we'll use inserts if it's a little more practical, but we'll get to that later. But here, if you just hover over it, you see it says mate. See, this says flush. What a mate does, it will make two faces touch each other. What a flush will do, it will make two faces on the same surface. So let's see what that means. Okay, so we're going to do a mate. Now notice here, a lot of people, the mistakes that they make is that they click here and think that's what they want to constrain. Well, if you see, that's not what we want. So I'm going to cancel there. I'm going to constrain. What you want to do is zoom in on your part. You can zoom in by scrolling your wheel. And see, I don't want this. I want this surface. Do you see the difference? This is a surface. This is the center point of that circle. I want this surface here. You got to be very careful about this. This is very important. So this surface, I'm going to mate that there. And then I want to mate it to this surface. I'm not going to click here yet. We're going to get to that later. Because if I click here, it's not going to do what I want it to do. I want this the surface up here to touch this surface here. I'm going to apply. Now what I want to do, so I need clearly this standoff needs to be over this hole. So what I do is I'm going to take, again, not this green center point here, but I want the entire axis of this. And what the mate does is it's going to put it through the axis of this. So see that? I don't want that green dot there. That's not what I want. I don't want this corner here. I want this green circle. Boom, right on top of it. Let me show you what happens if you constrain it to the outside. Like say I accidentally clicked here. It's not centered over a hole. That's not what we want. You can actually, what you can do is you can click here and you'll essentially redo your second constraint. So constrain there, apply. So now I'm just going to do this over and over. Apply there. I'm going to mate that axis with the circle there. I want to get my surface first. Now notice I'm doing the surface first and then the axial second. This is not completely necessary. It's just my personal preference. You could do the axis first But you can see now it's kind of down there. It just takes a little more time sometimes. Boom, there's our part. All right, so we got our first few steps down. Now what I'm going to do, I need to move this C channel. I'm going to put it on top of here. This is going to be the surrounding part for our wheel. But before I do that, I'm going to go ahead and start putting in some bearings. Now, your CAD library might be different from mine, but if it's not, then you can just follow what I'm doing. But my bearings are here. Notice I got all the kind of bearings. So we're just going to use a regular bearing for this one. Now, one more thing you can do, you can actually rotate the part before you place it. What this does, it might make it a little easier. So in this case, I rotated it to where it's going to be just about where I want it. So I'm going to place two of them, one for each side. Now what I'm going to do, I'm going to constrain. There's one mistake I made. I actually need this upside down so I can see, because I want the bottom of this bearing to be mated with this surface here. So what I can do is there's actually this free rotate tool up here. We're going to click that. Essentially, it's just going to let you rotate just that one piece. You can go all kinds of different directions. So I just want to get it to where I can see this surface here. So when I constrain, you'll see that this, I don't want this or that. This is exactly what I want here. I want this whole surface here to be touching this surface here. Now clearly this is not the direction we want it. So what we do now, we take the axial there, constrain it with the axis there. Hit apply, and then just take a second point for a bearing, constrain it there. I could have done the outside one, I could have done this one and that one, this one and this one. Doesn't matter as long as you can get it to sit straight. So I'm going to apply there. So now my bearing's constrained. Now what I'm going to do, I'm going to bring this piece. Well, before we do that, let's actually put this bearing on here so it'll be a little bit easier. So we are going to rotate this just like we did before. Hit constrain. I'm going to find that surface. Now be careful, you don't want the edge. This is just going to make it harder later. And apply that. Now, one thing, I should have probably mentioned this earlier, but let's say I made this and I want it right out here, but say accidentally I click something else like there. Okay, that's not where I wanted. That's not where I want it at all. So what I can actually do is I can click on this piece. Over here you see it's highlighted, that means it's the same piece. You can use the drop down menu and it shows you all the constraints that are on that piece. This constraint is fine, that's one I wanted, but this mate here was the wrong hole, so you can just right click and you can delete it. Now the piece is free to move again. So now I'm going to constrain. I'm going to put it on the right hole this time. It's right about here. I'm going to do another constraint. Again, you got to make sure you get that green circle. Zooming in helps a lot. So like that is not what we want. We want that green circle right there. There we go. Now what we want to do, we want to put this piece onto there. Now this piece will all move as one because this bearing is constrained to this piece of metal. So now this is very simple. We're going to constrain this surface to the top of this surface. Now remember, you don't want that green dot there. That's not the surface. This is the axial. This is the center point. This is the surface. You can see it highlighted. We're going to click that. So our C channel is right about where we want it, but still not quite centered. So what we're going to do now is we're going to take this constraint here, put it here, hit apply, take the axial constraint there with the circle there. See, now my piece is nice and square. Now notice I didn't constrain anything here because in Inventor, this will automatically lock it at a 90-degree angle from this one. So essentially, constraining here would just be overkill and there's no but as you can see, I could do it, but it doesn't move the piece at all because it's already locked in by these two constraints. So now we're getting somewhere where our assembly is starting to take shape. What I want to do now is, now you won't see me do this often throughout the tutorials, but I'm going to be placing screws in just to show you how. But very often, I do not put in screws because it just slows down the Inventor assembly. It takes a lot more time, and it's really not necessary for our applications. But if you really do want to do screws, go for it. Just be wary. It will probably slow down your computer if you don't have the greatest one in the world. But with that said, it's actually not that hard to do, but it will add a lot of time because assemblies have a lot of screws. So what we're going to do here, we're going to do the axis here. We're going to do the axis there. Now see, that lines up the axes of the part. But notice that made it kind of hard to see. So what I like to do, I like to mate the surfaces, just like I said before, because now it's really easy just to grab this screw, the axis there. You can see that dotted line, that's the key. I'm going to go to the dotted line here. Boom, my screw's constrained. I'm just going to do this for all of them. I'm going to mate the surface first. Just makes it a lot easier because I can see the screw here. And I notice this is kind of a cool feature of Inventor. I selected a constraint for this screw already. So what it's going to do is it's essentially going to now see through this screw. You see the white border when I try and go through the screw? Because it knows that I don't need to select something on the screw because you can't really constrain a piece to itself. So what I'm going to do, we got this axis here, and I'm going to find that circle behind it. I'm going to click there, apply. See, now our screws are nice and constrained. They can rotate, but that's okay. Alright, we're going to move our screws over here. Do the same exact thing, but this time, since I can't see both those holes, I'm going to click on this edge of the cube. It's going to rotate my view, make it a little easier to see those. And if you want to make it even easier, you can use that orbital tool from before and orbit it just to where you can see it. Now I'm just going to rotate these guys to face me. And now we're going to do the same thing again. Constrain, place, constrain, place. Line up the axes, apply, line up the axes, hit apply. So now we're getting somewhere. We gotta do screw bearings. Like I said, I'm just gonna show you that. That's how you would do it. There's really no need to go through and do all the screws in your assemblies, in my opinion. But if you did want to do it, that's how you do it. So now I'm gonna start going ahead and placing in some spacers. This is one of the great things of Inventor. You can actually figure out the exact spacing you need before you build it. Because a lot of people they'll just go in and start showing in spacers till it lines up. But here we can actually see the exact spacing that'll make your wheel fit just right. So I'm going to go ahead and start off with a 0.25 inch nylon spacer. I'll place a couple of those and see what happens. Now this is where we're going to use what's called the insert tool. This is really when you're going to be using it the most. Now I could do a mate on the bearing and then the axial mate, but this time it's easier. When an insert does, it does both those in the same step. So I'm going to take this circle here and insert it on this circle here. See that? It locks it in there. Now just to show you, well, you can't really tell, but this is rotating and it's able to rotate on that surface, so we know it's constrained properly. So I'm going to go insert again. Now sometimes, let's say I'm going to do this on purpose. See that? Our insert is facing the wrong direction, so sometimes you'll have to flip between these two. In this case, it was already lined up properly, but sometimes flipping it will get your spacer in the right direction. So I'm going to hit apply. Now I'm going to go ahead and place my wheel, because I think my wheel's further enough away now. So I'm going to go down to my wheels and we'll do a 4-inch Omni. That's a common. So I'm going to place once, right click OK, just like normal. So move this a little bit to the side. Now what's interesting about these is that some of the wheels don't have this nice circle to use here, but I can show you that you can actually use any circular feature close enough to the that is centered at the origin of this wheel. So I'll show you what that means. So I'm going to go insert. So you don't have to just use this. I could use this circle. I can use this circle. I can use this circle because it works off the center point. Just for ease, I'm just going to use this center point here. So I'm going to insert this circle onto there. And then I'm going to orient my view to the side to ensure that that's working properly. I'm going to click right here. Alright, so that looks good, because if it was like that, I could tell that something's wrong. So in this case, it was okay. So now we can see, alright, there's spacing here that we will be able to turn. Maybe I put a little too much spacing here, but it's enough for it to work, so we'll just leave it as is. And now, this is kind of cool. What you can do is you can go to inspect distance. Now it's a little finicky, but I'm going to do the distance from, say, this point to about that point. Now you can notice it's not exactly a straight line. In fact, it's a complete diagonal, so I'm going to go ahead and redo that. So you can just go to distance. I'm going to do this line to that line. So 0.25 inches is, in fact, that's even slightly angled. So we know that now a 0.25 inch spacer will leave just a hair's length of space for wiggle room, which is great actually, because we don't want this to be tight. We want just enough wiggle room for this wheel to be able to spin freely. So now I'm going to go ahead, go back to my Assemble tab. I'm going to place. I'm going to go to my spacers again. Now a 0.25 inch spacer is the same thing as an axle collar. They're roughly the same. So I'm going to actually go ahead and just put a collar on there because that'll prevent our wheel from moving. So I'm just going to place that. I'm going to take my insert tool, move it to the side a little bit. I'm going to select the axle collar. I'm going to select the circle here. Notice how I kind of did that from the side. Inventor is able to do that, but you could more than welcome to rotate it and try and get in there. Now let's say you were having a really hard time getting that in there and you couldn't see. One other cool feature, you can actually select this wheel, go over here to the sidebar again. You can right click it and actually turn off visibility and hit OK. The whole part is still there. It's still here. You just can't see it. But that allows me to work with this a lot more. But you notice there's no wheel, but I can easily just right click it, turn the visibility right back on, boom, the wheel's back. But yeah, if you were having a hard time getting the axle collar in there, you could turn that visibility off, rotate your view, look at that, and then do all kinds of stuff. Alright, so I'm going to hit home again. I'm going to turn that back on. Now one more thing that we got to do, we need our axle. And I did use a 2-inch standoff, so a 2-inch axle should be perfect. I'm going to go ahead and place, now this is assuming there's no motor on it, but that's alright. I'm going to go to drive shafts. I'm just going to put a 2-inch in there. Now I personally like using the mate and mate method is what I call it, and versus the insert method. Now, okay, notice what I did there. There's actually a circular feature to this axle. Like, it's kind of hard, but if you look here, that'll get you the center axial of the axle. So what you do is you take that center axle, like we just did here, and we're going to mate it to that. Make sure you get that white dotted line. It's very important. Boom, we got it constrained in there. However, we don't know. It's in there, but we don't know if it's exactly how we want it. So I'm going to pull it out. What I do now is we're going to use that flush tool. Let me show you what a mate will do. A mate, let me just show you the difference. A mate, I'm going to mate this and this. Essentially what it did, it made these two surfaces touch each other. It's like if you were facing someone. But instead of facing someone, you just want to be looking in the same direction. So instead I'm going to do flush and see how now this surface is on the same surface. If you go to the side, you see the axle is exactly flush with this surface here. You can't see it. A mate brings it out. A flush puts it facing the same way. So, with that said, I'm just going to rotate my view a little bit. We're going to hit apply. And now we've got our axle in there. Now remember, you could have done screws here to maybe test the spacing to make sure your screw heads didn't hit your wheel. It's very simple. You just do the insert like before, or the mate method. Either one will work. But as you can see now, we have a wheel assembly. What we're going to go ahead and do is we're going to go File, Save As. Now what I like to do, I have a folder called Subassemblies. What all that means is if I ever want to place an entire assembly instead of trying to hunt down the part somewhere, so in this case I will call it a wheel mount for whatever you guys want to call it. So I'm going to go ahead and save that, because now I just hit yes to all. Don't worry about that. And the reason why we want to save as a subassembly, because now if I go to a new assembly, now I can actually navigate to my subassembly folder. It's actually over here, but don't mind that. Now that whole wheel mount, instead of making that whole wheel mount again, now I can just place the entire wheel mount with all the constraints in there, as many as I want. I'm getting a little crazy here, but you can see the point. So instead of going through, okay, I mate these standoffs, mate these axle collars, do all kinds of constraints, now I can just place the entire assembly. This will make CADing a lot faster. Alright, and that's it for this video. Thanks for watching.